Hello and welcome to another video from sickmaths.co.uk where you can find lots of free maths videos. This video is about equations of graphs, the basic stuff. What we're going to do is turn these equations into these graphs. How do we do that? Well, can you see these coordinates over here? We're going to generate them using this equation. Now, every one of these coordinates has an x part and a y part. For example, if I look at this coordinate here, it has coordinate 1, 3. The x value in the coordinate is 1, the y value is 3. Now, this equation connects x values and y values. If, for example, I make a table like this and I fill in just the top part, 0, 1, and 2, okay, because I'm going to make 3 coordinates in a second. Okay, I put x equals 0 into the equation. I get 2 times 0, which is 0, plus 1 equals 1. So that means y equals 1, because y equals the result of all of this. Okay, so I've put that there. Let's put another number in. So x equals 1 goes into there. 2 times 1 is 2, plus 1 is 3. So I put 3 there because y is equal to 3. Okay, and for that one, 2 times 2 is 4, plus 1 is 5, so that goes there. So I've made a little table starting off with just x values, put the x values in, and out come out the corresponding y values. Okay, and therefore I've just made my coordinates. So 0, 1 is the first coordinate, 0, 1 is there, 1, 3 is another coordinate, 2, 5 is another coordinate. Simple as that. That is actually the slow way. Oh, and forgot. Connect those points together and you get your line. Okay, all of these, because it's the basic stuff, all of these ones are just straight line graphs. You can make curvy graphs as well. And bear in mind that I could have chosen other x values, but I just chose those ones so I can fit it nicely into this graph. Okay, and it makes sense to put them next to each other rather than completely spread out. Otherwise I would have had a dot here and a dot a million miles up there, a million miles behind. I thought I'd choose x values which are next to each other. Now, let's do it the quicker way. There are some things you have to look out for in the equation that will help you draw the graph very easily. There are two things: the number in front of the x, which will tell you the steepness of the graph, which you'll see over here, and the number at the end, if it's written in the right order, y equals something x plus or minus a number. Yeah, and the number at the end will tell you where it's going to cross the y-axis. So as you can see, that -1 tells you it's crossing the y-axis at -1. That is actually called, that number in the end is called the Y-Intercept, i.e. where your line intercepts the y-axis. Okay, and the Y-Intercept is -1 here. And the number in front of the x, okay, is your gradient. In this case, it's 3 over 2, which means it goes 2 across and 3 up, or 3 up and then 2 across, whichever way you want to, okay, for every step. So I start from -1, and then I go 2 across, 3 up, make a dot. And I could have gone 2 across, 3 up again, but I don't really need to. Once I've got a dot here, and I know this point here, I can make a line as long as I want, because this I know is a straight line graph. How do you know it's a straight line graph? As long as it's y equals a number times x plus or minus a number, that is a straight line graph. Anything with the x squared or anything more funky than that, x cubed, 1 over x, sine x or something crazy like that, that is not going to be a straight line graph. But these ones are. You can see they're quite similar to each other. Y equals something x plus or minus a number, y equals something x plus or minus a number, and y equals something x plus or minus a number. So you can write it in slightly different ways. You can rearrange it. You can say y equals a number plus or minus x or something, whatever, but that, you get the rough idea. You can rearrange it slightly if you want. And that's that graph done. let's talk about this final example. It doesn't really change much from there. There is an important idea to realize that sometimes you don't get a fraction, like in this case and in this case. In this case we got a fraction before the x, but both of these cases we didn't. Now what happens then? How do we know how much to go across and how much to go up? Well, you can turn this whole number into a fraction, i.e. turn it into minus 2 over 1. Okay, the minus, first of all, just makes it go the other direction. Positive gradients are like this and like that. Okay, but negative gradients, okay, are like that. Now, the 1 bit tells you how much you're going across, and the top bit tells you how much you're going up or down, whichever way. Vertically is the idea. Okay, so I know I'm going in this direction, and this is how much I go across for every step I go vertically, like this. 2. Okay, so I go 1 across, 2 down, 1 across, 2 down. Or I could have said it the other way around. 2 across, 1 up, 2 across, 1 up, as long as I'm going in that direction, because it's negative. Okay, and of course, that number plus 4 at the end is the Y-intercept, i.e. where our line intercepts or crosses the y-axis. And that's how simple it is. Now, the really basic ones I've done left for the end, which is how to draw the graphs that are exactly vertical or horizontal. Okay, y equals 1 crosses the y-axis at 1, and every coordinate on there also has the y component of the coordinate is always 1. So for example, if I take this coordinate here, that is 2, 1. If I take that coordinate, there is 1, 1. That coordinate there is 3, 1. Every coordinate on there, even over here, say minus 1.5, 1. Okay, it's always got a 1 in the y part of the coordinate. Okay, throughout. This one over here has x equals 3 throughout the line. So every part of the coordinate, the x part of the coordinate on every single coordinate is 3. So here we go again. So this is, let's pick that one. That is 3, 4. This is 3, 0. This is 3, 1. Yeah. This one over here, every single coordinate on here, the x part is equal to minus 2. So this is minus 2, 0, minus 2, 1, minus 2, 2, etc., etc. Oh, minus 2, minus 1. You can go negatively as well. They go on forever that way and that way. These ones go forever that way and that way. Just like all these graphs, they go on forever in each direction once you got them going. And that is it.